All right, Calc BC, we're doing 8.1, number 53. And 8.1 is sequences. So this is one that some people have had a problem with. What is the limit of the sequence with an nth term of a to the n equals n sine of 3 pi over n? And so first of all, you could L'Hopital this, but L'Hopital is an 8.2, and so you might say, Cooch, that's not fair, because L'Hopital, we haven't learned that yet. And so I'm going to do it without L'Hopital because of that. So I want to take the limit as, in this case, we have n goes to infinity of n sine of 3 pi over n. And so if you get that, you get, well, that's infinity times the sine of 0, which is infinity times 0. And so obviously that's not conclusive. That's what we would call indeterminate. So what do? We're going to do a little manipulation. We're going to go ahead and we're going to remember back to in previous chapters, chapter 2 specifically, that we know that the limit as, let's just say, h goes to 0 of the sine of h over h equals 1. And we know that from chapter 2. We've done that in we've done that in other chapters as well, but definitely in chapter 2 a few times. Okay? And what I want to show you is that these two functions, these two terms are actually really similar to each other. So let's go ahead and let's take this and let's get this into that form. So we're going to do the limit as n goes to infinity of the sine of 3 pi over n, and we're going to do over 1 over n. Now, these two parts here aren't the same yet. I want these two things to be the same. Just like h is the same as h, I want this 3 pi over n to be the same as this 1 over n. So I need to multiply this down here by 3 pi over 3 pi. So I'm going to multiply this by 3 pi. And of course, if I multiply the denominator by 3 pi, I need to multiply the numerator of this by 3 pi as well. So then now I have the limit as n goes to infinity, and I'm going to pull this 3 pi out front. So 3 pi times the limit as n goes to infinity of the sine of 3 pi over n over 3 pi over n. And now what I want to show you here is you have what you need. This is the same as this, but we're going to infinity. And so if I evaluated that, I would get the sine of 0 over 0, and then I have this 3 pi out front. But that's just 3 pi times 0 over 0, which isn't really helpful. But let's remember back to the fact that this is this in hiding. Let h equal 3 pi over n. Okay? If h equals 3 pi over n, then we have the sine of h over h. Now the question is, what is our limit? And I would argue that when n goes to infinity, like we have over here, we know that h goes to 0. Right? If n goes to infinity, doesn't h go to 0? And so we have this. And what do we know? If we have the limit as something goes to 0 of the sine of that same something over that same something, we know that that limit is in fact 1. And so what is our something? Our something is 3 pi over n. Right? And so we know that when n goes to infinity, 3 pi over n goes to 0. So what we have now is 3 pi, let me change my color back to the purple. We have 3 pi times, we already showed over here that this limit is 1. And so our answer is 3 pi. So our answer is D. And if you do L'Hopital, it's going to work as well. To do L'Hopital, you do the same first step. Okay? You do the same first step. what you do is you just go ahead and this step right here, you go ahead and you do the limit as n goes to infinity of the sine of 3 pi over n over 1 over n, and that equals 0 over 0, indeterminate form. And so you just L'Hopital it, and you're going to get some cancellation and some cosine action in there, and you'll get the same answer. Okay?